Hello all, this is Mr. G, and in this video we're doing Chapter 4, Section 7, and after this lesson you should be able to use the discriminant to determine how many real solutions a quadratic equation has. The discriminant is something, it doesn't give us the real solution, it tells us how many real solutions there are. So let's take a look at what the discriminant is. The discriminant is b squared minus 4ac. Now I'm going to preface all of these notes we're going to do with sort of a disclaimer. I think the discriminant is kind of stupid. I don't like using the discriminant. I pretty much never do use the discriminant. But if I let you get through this whole course without at least hearing what the discriminant is and what it does, that would be me not doing my job. Because next year, your math teacher is going to expect you to know what the discriminant is. So that's why we're talking about it. And how do I want to say this? As we go through these notes and these examples, I'm going to hopefully show you why I think the discriminant is kind of stupid and why I don't really end up using it all that much. So this is what it is. It's b squared minus 4ac. And remember, this tells us how many real solutions a quadratic equation has. There's three different possibilities. The discriminant can be positive, it can be equal to 0, or it can be negative. So let's take a look at each one of those individually. If the discriminant, b squared minus 4ac, is greater than 0, then there's two real solutions. If it's positive, there's two real solutions. If it equals 0, if the discriminant equals 0, then there's only one real solution to that quadratic equation. And if the discriminant is negative, there's no real solution. If it's less than 0, if the discriminant is less than 0, then there's no real solutions to that quadratic equation. Now, okay, this seems kind of useful. So I wouldn't blame someone who's watching and thinking, well, why does Mr. G think this is so stupid? Well, here's why. This should look really, really familiar, that discriminant. We just used that in the quadratic formula. That b squared minus 4ac is what's under the square root in a quadratic formula, or in the quadratic formula, I should say. So let's dig a little bit deeper and say, okay, so what's going on here? Why does this work? So let's see, we've got the quadratic formula, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, what if the discriminant was positive? So if the discriminant is positive, that means, okay, we've got some positive number in here. I'll just pick one. I don't know, 25, whatever. So we get negative b plus or minus the square root. Let's say the discriminant is some positive number. I just picked one, 25. And we're going to divide that by 2a, whatever that is. I don't know what b is, I don't know what a is, but I know the discriminant is positive. Well, let's see, that would be negative b plus or minus the square root of 25, that's just 5, and then divide that by 2a. So let's think back. If the discriminant is positive, then we should get two real solutions here. Why is this going to give us two real solutions? It's right here with the plus or minus. We're going to have to add 5 and subtract 5. When we add 5, we're going to get one real solution. And when we subtract 5, we get a second real solution. That's why when the discriminant is positive, we end up with two real solutions. Okay. What if the discriminant is negative? If the discriminant is negative, then all right, so we have negative b plus or minus the square root of, I don't know, let's pick negative 25, doesn't matter. All divided by 2a, we don't care what 2a is, but as soon as we try to go to the next step, we can't do anything because we cannot take the square root of a negative number and get a real solution. We can't get a real answer out of this. So since the discriminant is negative, there's no real solution. Now let's take a look. All right, what if the discriminant is 0? So it's negative b plus or minus the square root of, okay, the discriminant is 0. Remember, the discriminant is whatever's under the square root of the quadratic formula. Divide that by 2a. Let's see, that's negative b plus or minus the square root of 0 is just 0 divided by 2a. So if the discriminant is 0, if we remember our notes, we should be getting only one real solution here, not two. And that makes sense because even though we're adding and subtracting, whether we add 0 or subtract 0, we still end up with the same answer. It's just going to be negative b over 2a, whatever that comes out to for this problem. So there's only going to be one real solution because adding 0 and subtracting 0 gives us the same thing. And again, I can understand some people watching and saying, okay, well, why does Mr. G hate the discriminant so much? Why does he feel like it's so useless? I mean, it seems like it's got a use for it. Well, there's two main reasons I don't like it. The first reason is that, like, if you look, how do I want to say this? Even if you've never heard of the discriminant, you still could have answered all these three questions. Like, if you take the discriminant out of it, okay, if I just replace discriminant with b squared minus 4ac. If whatever's under the square root is positive, oh, we can see there's two solutions. And again, okay, if we take discriminant out, okay, if whatever's under the square root is negative, oh, we know that's no real solution. And okay, if again we take it out, it's just whatever's under the square root. If that's zero, oh, we only get one real solution. Just by knowing how to do the quadratic formula, we can already answer these questions without needing the discriminant. So that's one thing where I don't feel like it provides a lot of value as long as you're really good at the quadratic formula. The other thing that I sort of have a problem with is it gives, not an obstacle, it doesn't create an obstacle, but it gives people another chance to make a mistake. So like say someone's going through this and they're doing a discriminant problem, they're like, oh, okay, I got a discriminant of 7. So the discriminant was 7 for my quadratic equation. Well then, okay, how many real solutions would that be? If it's 7, if it's that means it's positive, so there's 2 real solutions. If the discriminant is 7 in this made-up problem I just did. But a lot of people will do this, say, oh, the discriminant 7, that means there's 7 real solutions. They're like, no, 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 no. That's completely impossible. It's either 2 real solutions, 1 real solution, or no real solutions. So that's why I'm not really crazy about the discriminant. It's not really necessary, and it just creates another opportunity for people to make a mistake. But let's practice a couple examples. We'll do 2 together, 1 on your own, and that'll be the end of this video. So example 1 says, how many real solutions does the equation 5x equals 13x squared minus 22 have? We got to find all the real solutions. Okay, so it's asking how many real solutions are there, and then we have to find all of them, however many there are, and round our answers to the nearest 100. Okay, so let me rewrite this equation. So it's 5x equals 13x squared minus 22. So to figure out how many real solutions there are, I'm just going to start finding them. And the quadratic formula will tell us how many real solutions there are, because the discriminant is built in to the quadratic formula. We need this in standard form. We need a 0, so let's subtract 5x from both sides. So we get 0 equals 13x squared minus 5x minus 22, making sure this is standard form of x squared, x to the first, and then our constant last. And now we can go straight to the quadratic formula. We know a equals 13, b equals negative 5, and c equals negative 22. Hopefully we're pretty good at using the quadratic formula from our last video, so let's jump right in. We know x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's substitute and simplify at the same time to make this a little bit quicker. So let's see, I'm going to grab a calculator for myself. Negative b, that's going to be positive 5, because minus a negative b becomes positive, plus or minus the square root. B squared, that's negative 5 squared, that's going to be positive 25, minus 4ac. So this is the most important part. We got to know what sign goes there. Not, well, one of the most important parts, we can say. Let me see. It's going to be 4 times 13 times negative 24. So it's a negative 4 times a negative 22. It comes out to a positive. And then I'm just going to use a calculator for that. 4 times 13 times 22. That's 1,144. All divided by 2 times a. That's 2 times 13. That's 26. Now, at this point, we should be able to answer the first question. We should be able to look ahead, sort of look into the future and say, okay, based on this, how many real solutions are we going to get? The radicand there, remember the radicand is what we call something that's under a square root. In this case, it's the discriminant. The discriminant here is going to be a positive number. So that means we're going to get 2 real solutions. 2 real solutions. Now, if any of you are watching this thinking, well, I don't know if I would have been able to see that there's 2 real solutions right there. Don't worry. If you just keep on going, eventually you'll find both of them. And then it'll be like, oh, we found 2, so there's 2 real solutions. So even if you don't know there's 2 real solutions right now, let's just keep on simplifying, and you'll see that we get 2. So let's see what happens. This is going to be x equals 5 plus or minus. Now, one thing the directions said is that we can round our answers to the nearest 10. That's going to make this a lot easier because we don't have to worry about simplifying the square root. We can just sort of take estimate the square root in a calculator. So let's see. It's going to be square root 1144 plus 25, that's 169. Excuse me, 1,169. All divided by 26. I doubt that's going to be a perfect square. I think we're going to be estimating at this point. So second square root, 1,169. Hopefully you're following along with the calculator. Don't just sit there and watch. Make sure you're practicing these steps. And we get 5 plus or minus the square root of that is 34.190. So it rounds to 19. All divided by 26. or jump. Now we can get to our two answers. So I'm going to do it once on the calculator with addition and then once with subtraction. So first I'm going to add. So 5 plus 34.19. I hit equals. You have to hit equals there. Otherwise, you're not going to get the right answer. Then we divide by 26, and we get 1.507. So we'll say 1.51. That's our first answer. Then the second answer, we're going to subtract. So I hit 5 minus 34.19. Hit enter or equals. Then I divide that by 26, and we get negative 1.122. So we'll say 12, just 12. And those are our two real solutions. So even if, like back here, you didn't see that we're going to have two real solutions, you couldn't think that far ahead, that's fine. Just keep on going, and eventually be like, oh, look at that, we got two. So it's two real solutions. They're 1.51 and negative 1.12 approximately, rounded to the nearest hundredth place, the nearest second decimal. Let's do another one together. How many real solutions does the equation negative 11 equal 22x squared minus 4x have? Then find all the real solutions, and we're going to round our answers to the nearest hundred. So let's rewrite this here. Negative 11 equals 22x squared minus 4x. We want this in standard form, so let's add 11 to both sides. It's going to be on the end, so we get 0 equals 22x squared minus 4x plus 11. Okay, I mean, I guess we could try and factor this, but a lead coefficient of 22, I don't want any parts of factoring that. Let's just go straight to the quadratic formula. Because remember, we don't need the discriminant. That's built into the quadratic formula. The quadratic formula itself will tell us how many real solutions we're going to get. Let's jump in. So that's going to be x equals, I think at this point we should be okay skipping writing the quadratic formula. If you want to write it and show all your work, that's fine. But I'm going to try and speed this up a little bit because the video is going to be way too long if I show every single step. So it's negative b, that's going to be positive 4, plus or minus the square root of b squared, that's 16. B squared minus 4ac, so it's minus, oh, is that going to stay negative? It's 4. It's going to be negative 4 times 22 times positive 11. Yep, there's no negative there to change it to a plus, so it stays minus. And I'm not doing that in my head. 4 times 22 times 11, we get 968. All divided by 2a, that's 2 times 22, that's 44. So we're sort of showing here how you can speed these problems up by not showing every single step. But if I confuse you by doing this, by sort of skipping those steps, just go back, do a little bit more practice with the quadratic formula problems we did in our previous lesson, and you'll be able to get there, I'm sure. Or just show all your work, and you'll be fine. Okay, now how do I want to say this? At this point, we can see we don't have to do anything else. We don't have to do a single other step because the discriminant, what's under that square root, is going to be a negative. So that means we're going to get no real solutions. No real solutions. But let's say a student didn't see that. Like, let's say someone's working on this problem and they don't see that. Well, what would happen? Well, we just keep on simplifying. So that'd be 4 plus or minus the square root of 16 minus 968. That's going to be negative 952. All divided by 44. And let's say the student still doesn't see the problem. Okay, next I got to take the square root. Just keep following their PEMDAS. So second square root, negative 952, and we get an error. On my calculator, it says non-real answer. So that's essentially the calculator telling you that there's no real solutions. So again, I'm just showing that you don't need the discriminant. You don't need to know any of the discriminant rules. The quadratic formula takes care of it for you. But the only thing is, like I said, you need to at least have heard the word discriminant because your math teacher next year very likely will expect you to know what the discriminant is. So I want you to be prepared for that. Okay, here's example 3. Try this one on your own. Come back when you think you have an answer. 3, 2, 1, let's go. So how many real solutions does the equation negative 16 equals x squared minus 8x have? Find all real solutions, round our answers, blah, 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 blah. Let's get to work. We need 0, so we add 16. We get 0 equals x squared minus 8x plus 16. Let's see. Let's go straight to the quadratic formula here. Even though I think this might be factorable, so if you want to factor, that's fine. But I want to show you what it looks like in the quadratic formula. So I just wanted to mention, I believe you can factor this, but we're going to do it the long way, just to make sure everyone can see what it looks like when this happens in the quadratic formula. So x equals negative b is positive 8 plus or minus the square root of b squared. That's negative 8 squared. That's positive 64. B squared minus 4ac, so that's going to be negative 4 times 1 is 4 times 16 is 64. Yep. Then that's all divided by 2a. That's 2 times 1, that's just 2. And if you're thinking ahead, you already see this, but let's just follow the steps. Let's pretend we don't see it. So it's 8 plus or minus the square root of 64 minus 64 is 0 over 2. Now, if you're thinking ahead and you understand how this formula works, you're thinking, oh, we're only going to get one real solution. So the first answer, or the answer to their first question, is one real solution. One real solution. Now it's just up to us to find that real solution. But let's say I'm a student and I didn't see that it's one real solution. I didn't recognize that the discriminant is 0 tells us that there's only one real solution. Well, we just keep simplifying. So let's see what happens. This becomes 8 plus or minus, the square root of 0 is 0, divided by 2. And then 8 plus 0 or 8 minus 0 is just 8. 8 divided by 2 equals 4. So there's one real solution, it's x equals 4. And we're done. So we saw one example where the discriminant was positive, one where it was negative, and one where it was 0. It's actually pretty uncommon for the discriminant to come out to be 0. Usually a math teacher has to sort of bend over backwards to make that happen. But, I just wanted you to see at least one example like that. Here's your homework. I want you to do page 245, numbers 25, 28, and 31. These problems are very similar to what we did. It's essentially saying how many real solutions there are, and I'd like you to find those real solutions after you answer how many real solutions there's going to be. As always, hopefully this makes sense. If you have questions, let me know. Enjoy the rest of your day.